we just talked about 6 marbles, 3 blue, 1 black, 1 red, 1 white. What are the chances? What are the odds? What is the probability of you guys picking a blue? Joe said 1/2. We figured out that came from 3/6. That can be written as a decimal 0.5 or 50%. So why are these big numbers? 3 ways, 8 ways, 676 ways. Are we doing probability yet? 5,760,000 possible outcomes, or maybe total outcomes that fit certain conditions. So in section 9.6, aren't we just learning how to, hey, you get the section title? We're just learning how to count, because in my example, if I said how many blue, wasn't it easier? Well, somewhat easy, maybe easier for some than others. For you guys to be like, oh, 3 blue, 6 total, 1/2, done. Right? But do things get trickier than that? Yes. So therefore, in order to prepare us for trickier, we have these fundamental counting principles, and one of them is, instead of actually writing out all the different possible ways something could happen, is trying to mathematically analyze. And one of those steps towards that is saying, okay, if I'm trying to, for instance, put 2 things together, like 2 pairs of letters, or a license plate which has numbers and letters, or whether I was doing like a telephone number with different combinations that couldn't start with 0, or had a certain set area code or certain set area codes. If I had arrangements of letters, there are different things for us to be thinking about that can simplify what we need to come up with as far as knowing how many ways something can occur. Whether it's the favorable or whether it's the total, both are going to be important for probability. Okay? So in section 9.6, literally we're counting up, but we're counting up in a way that we don't have to write it all out, because that would suck. So coming here, permutations, that was a new word yesterday, right? Permutations, what was the most important other word on this page to relate with permutations? Order, good. Order is important, order matters, etc., etc., etc. Now there is a factorial formula, that's going to be important. We did see the batting order. Was that the very end of yesterday? Yeah, very end of yesterday. The batting order, why would we need a permutation? Why not just use factorials? Because it totally worked back here. 6 factorial and you're done. But why was this one so easy, just 6 factorial, and this one was harder, needing 15 factorial over 6 factorial? What was the difference? Yeah, there wasn't enough spots. We weren't using everybody. We weren't arranging everybody. Let's say I only had 5 chairs and I had 20 of you, and how many ways could I sit you guys in the 5 chairs? Well, 15 of you aren't going to get a chair no matter which way I go, right? Same thing here. So I can't use 15 factorial the whole thing. Well, I am going to use it, but I'm going to take away those spots that don't get to be filled. Does that kind of make sense? Okay. So this one, the top one, the simple factorial, that's only if you're using all of the objects. So like this one, you had 6 letters, you were arranging all 6 letters. So 6 factorial, you were good. But this one, as soon as you have more objects than you are using, well, then we're going to have to use NPR in the sense of actually thinking of it's only part of that factorial. Is it possible to have fewer objects than you're using? Well, if you're willing to go to the store. Anyway, no, we're not going to be arranging fewer objects than we have. Sorry, we're not going to be arranging more objects than we have. So we don't have to worry about R ever being greater than N. If it was, well, you're being given an impossible problem. So don't worry about that. Beep, beep. But we do have to worry about this. We do have to worry about this. What if there are repeats? Now, to be honest, that formula at the top of the page, I don't like at all. There's just not a great way of showing it. There's not a great way of writing it. There's not a great way of showing it. So I'm going to have to use words to explain it. So the formula itself, it's okay. You can put little quotations around it, or you can put, I don't know, like parentheses around it. Like, it's not horrible. It's just not great. You need some words for this to understand what's going on. You need some words for this to understand what's going on. So if I were you, if you're a highlighting kind of person, guys, this particular page is one that a lot of people underestimate. Not that it's like a huge topic on the test. They just don't think of studying it. So you might just want to make a little colored highlighted note about repeated objects. And don't just highlight the formula. It's not enough. You have to understand how it works. What does N stand for in context of what we've been doing this section? How many people, objects, things, letters. Is that cool? N, how many? But why is there an N up top and then other N's down below? This top N is the, well, that's confusing even just showing that. Let's do here. The top N is just total. The total number altogether, all the letters, all the, in this example down below, 3 B's and 5 T's, right? 8 total letters. So for this one down below, N is 8. Down here, N sub, we could do N sub K because they use this K, which is sometimes 1, sometimes 2, sometimes 3, is the number. So total number versus the number of each type. Of each type. Not type as in letter, because they're all letters. I mean, in a license plate, that would be different, because we'd have numbers and letters. But here, the little N1, N2, N3, the number of each type. I'm playing with my pen, I'm sorry. I shouldn't hold pens that have tops. If N is the number of each type, well, guys, what types of letters do we have? B's and T's. So if N sub K stands for the number of types, we only have 2 types, right? So couldn't I say, okay, fine, if I'm arranging all of these letters, they didn't tell me otherwise, I'm assuming like with A, B, C, D, E, F, the example from yesterday, we had 6, we were arranging 6. I'm going to assume that we're allowed to arrange all 8 of them, we're using all 8 of them. But what's the problem with me saying there are 8 factorial different ways of arranging these? If we started with our 8 blanks like we did with our batting orders, see if I can fit it. 1, 2, 3, 4, 5, 6, 7, 8. How many different letters can go here? Technically 8 different letters, but 2 different types. Does that make sense? Now it starts to get a little bit complicated because it's like, well, if I say 2 types, 2 types, 2 types the whole time, that's impossible because I only have 3 B's and I have 5 T's. If I do 8, 7, 6, 5, 4, 3, 2, 1, like, yeah, I can do that many arrangements, but let's just say, instead of dealing with all 8, because that's hard, let's say I talk about my B's. Just my 3 little B's. These 3 B's, couldn't I arrange those 3 B's in 3, 2, 1 different ways? Those 3 B's. And then how many ways could I arrange my T's if I just had T's? 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. But here are my questions. Well, I guess it's really just one question, but it's for both. No matter how many ways I rearrange these B's, isn't it still going to be B, B, B? And no matter how many different ways I rearrange my T's, isn't it going to be T, 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 T? So this would tell me all of those are different arrangements, but your brain just told you no, they're the same. So what are we going to do? The same way in the batting orders, we had to take out the 6, 5, 4, 3, 2, 1 because it didn't apply. We have to take away the 3 factorial and the 5 factorial because rearranging those B's won't make a difference. Rearranging those T's won't make a difference. And the nice thing is, mathematically, by that division, we're taking away all the different, oh, let's just switch those 2 T's. Oh, it's not different at all. Let's just switch those 2 B's. Oh, it's not different at all. Now, hold on, these aren't like colored B's and colored T's. Would that be a different thing if he was red, he was yellow, he was black? Yeah, that'd be different. But if we're just talking about the letters, well, they're not different if you rearrange the B's. It's the same word that's not really a word. So do you guys see how the formula kind of works? Total N is on top, and then how many B's, how many T's, and that's all we had, so good. But what if I was to throw something, or maybe, what if I was to change this last T to like an H? Would I still have 8 total? I took away the T, sorry. Yeah, now it's going to be 8 total. How many B's do I have? 3. How many T's do I have now? 4. and 1. But guys, do we ever have to worry about the 1? So we can write it because, yeah, there is an h, but is it going to make a difference? No. So all that we really, really, really need is the total, and then the number of repeats down below. So you guys, ready, set? Uh-oh, well, wait a minute. Who is this guy? What do we do? 6 times 5 times, who goes away? Oh, I was going to take the 4 away, just because I'm lazy. Is that okay? And then 1, 2, 3. Can't 2 and 3 take away 6? And the 1. So 8 and 7 is, oh, we have 8 and 7 and 5. That's okay. 56 times 5 ends up being 180? No, whoa, whoa, whoa. Yeah. 56 times 5 is 30 and 25. So I took away my biggest factorial. And I had 1, 2, and 3 is 6, so I took away the 6, and then I had to multiply who was left. Ready, set, your turn. Algebra, go. Whoops. Well, I know, should have been Mississippi. Don't worry, that one's in homework. The letters of Mississippi, rearranging them. I think so. Otherwise, I think I would have used it, because Mississippi isn't that like the most common repeated letters word ever? M-I-S-S-I-S-S-I-P-P-I. Mississippi. 4. 1 M, 4 S's, 4 I's.
I just can't spell that.
2 P's, right? Just 2 P's? Yeah, right? Yeah. M-I-S-S-I-S-S-I-P-P-I. Mississippi. Someone's like, you're weird. What are you guys doing for this one? Who's your N for algebra? 7. How many A's? How many everybody else's? Well, this one's boring. We should have done Mississippi. It's still in homework. Do you want me to do all the 1 factorials, or can I just not write the ones? All right, thank you. I didn't want to. So then you end up with, oh, but simplifying is fun, because what do you have? 7 and 6 and 5 and 4 and 3. The only guy that's gone is 2 and 1. Well, that didn't really help. Maybe it's not too bad, because that's going to be 30 and that's going to be 12. It's going to be 360. You just have to do 360 times 7, which isn't super fun, but 0 and 2 and 4. Yeah, I agree. Look at our mental mathers. And calculator people. Okay, either way, using your resources. Okay, so. Ready, set, whoo! How about that one? Professions. You can think of it as a job or as a declaration of something important. If you're professing something. How many, Priscilla? What do you guys got? 3 S's. 2 O's? I think that's it, yeah? Now, this one you would definitely be able to use a calculator for. There's no way we're doing mental math with 11, 10, 9, 8, 7, 6.
4, 9.
5, 4. 5, 2. There you go. Because the 3, 2, 1 would go away, and then the 4 would reduce with the 2. Either way, it's huge. But here's my question to you. Hey guys, in your calculator, is there an NCR button? Yeah. Is there an NPR button? Yeah. Is there a repeated objects, how to do NPR but with repeats button? Yeah, but there's not. So instead, you're going to have to use the factorial button. And where's the factorial button? Exclamation point, either underneath math and prob. Or isn't there a shortcut to it underneath, what's the nice one, alpha window? Yeah. And couldn't you use your little alpha fraction too and make it all nice and pretty and neat? What'd you guys get? Ooh, slower, Matthew. I don't know. Someone else? What'd you get, Jason?
I got 1,663,200.
Uh-oh. We have a 1 million and a 3 million. Who else wants to chime in? Ah, Wesley got a 3 million. The same one? Yeah. Try again, Jason. Now, if you're doing the division sign and not the fraction sign, you have to put parentheses around your denominator, right? Awkward. Silence. I mean, most of you are using, how many of you guys are using the cool fraction like the top and the bottom? Okay, but anybody who's not, you just have to use the division sign and put that in parentheses, right? That was the old school way of doing it. Okay. Boop. Oh, wrong way. Sorry, Lo siento. Can I do one more? Ready? One more. Oh, I don't want to do that. I want to do a new page. No, I want to do a new page. There we go. How many? Last one for this. How many 4-letter arrangements of arrangements? How many 4-letter arrangements of arrangements are possible? 4-letter arrangements. Ooh, so you have lots of letters and you're only choosing 4?
What?
Well, there are repeats, aren't there? You're only choosing 4 letters out of all of them at a time. Could be 4 letters.
Does it just mean the...
But it could be R-A-N-G, or it could be A-R-R-M, or it could be R-A-N-S, or it could be...
Oh, you want us to make words?
No, not actual words. No, let's not play Boggle, even though Boggle's a great game. But, ooh. Tyler already counted up there are 12 letters, and she's saying 12 divided by 4. She's close, but not right.
12 to the 4th.
No, oh, no, not 12 to the 4th power. No, too exciting, Jason.
Just the same thing as the last problem? No, it's not 12.
Except the last problem, weren't we arranging all the letters? We're only choosing 4.
No, the last one, you only total, and then we divided by 4.
The last one. So what did we do wrong?
Oh, I knew. It's a 3-letter arrangement, and you have to eliminate actual possibility of repeating.
Well, we did eliminate the possibility of repeating. You guys did a great job on that.
There's only one possible outcome.
Let's do this one, and let's go back and correct the other one. Pause. Let's do the repeats, and then let's talk about the numerator. The repeats are great. You guys did a great job on the repeats. The 3 and the 2 was golden. So what would you do for your repeats here? How many repeats do we have?
4 repeats.
2 A's, 2 R's, 2 N's, 2 E's. We have A's and R's and N's and E's. Are there any more that are repeated? Okay. What's bad if I do 12 factorial in the numerator? Why am I going to erase that? Can we go back to the permutation card? We only use factorial when we're using all the elements. We're not using all the elements, so what should our numerator be? So maybe we need to go ahead and say or NPR. They could throw that at us, and they did, and we totally whoosh, right past it. So, sorry, in case you need it. In the numerator, it's n factorial or NPR. N factorial is if you're using all n. NPR is if you're using only some of them. So in this one, well, okay, we're only using some of them. So out of 12, how many are we using? 4. Now, if you were to need to write this with factorials, isn't there a factorial formula for that? So wouldn't that be 12 factorial all over 12 minus 4 factorial is 8 factorial? And can't he, because we're taking away options from that, right? Can't we just kind of join him together with all of those? If you don't like that, you could have also made this 12 factorial all over 8 factorial, and then this would be divided by the fraction, this over 1, multiplied by the reciprocal, but that doesn't sound very fun. So maybe we didn't need to be using our calculator at all. But I did want you to practice using your calculator, so it's not totally bad that we messed up the first time. But this one's going to be a little easier because it's 12 times 11, 10, 9, 8. And then isn't 2 times 1 just 2?
Yeah.
2 times 2 times 2 times 2 is going to end up being 16. Does anything go away with 16?
8, no.
No, but I can reduce away. Yeah, 4 goes in 3 times, and 4 goes in 4 times. And then I guess 2 goes into 4 2 times. And now I'm kind of stuck. Yeah, 3 times 11 times 5 times 9, or 15 times. And do you guys divide by 2? Uh-oh, I'm hearing 1180 and 1485.
11880.
Uh-oh.
Is that wrong?
Is that the same that you have, Jason?
I mean, I do all the calculations.
Sorry, Lauren, I was having too much fun simplifying. My 16 reduced with my 12 to be 3/4. And then my 4 reduced with my 10 to be 2/5. I was just being lazy and trying to do mental math, and then I gave up because I was like, meh.
But you used to have like 16 on the bottom of this.
I don't. I have a 2 on the bottom. But you could have had a 16. Anyway, so do we all agree with 11880? Okay. We are all in confusion. Does anybody have another answer they want to throw out there? 742.5? Oh, I put 7,000, Los Santo. Now, how does that get confusing?
How do you have a wider range? You just convert the fraction to the You don't have like 2 letters or like it contradicts the definition of this problem.
Selma, you just plugged in the factorials? Yeah, that's what I would have done too. This one is an odd number cut in half, which would go ahead and be, oh, I don't have my factorial. Yeah, I think it's an odd. Probabilities sometimes, even though it is helpful, it can be confusing. Meaning it can be imprecise. But the imprecise we still use because it can still be helpful, times 16. Yeah? Yeah, you guys are right. I don't think in our level, though, of probability, you're going to see, I just made that one up, and so it ended up being a half. But the examples you guys are going to see are going to be much nicer. Meaning, this one's going to be a nicer answer. It's going to make a little more sense and not be a 0.5. The other one was technically right. We just round up or round down, depending on what kind of accuracy we want. How do we need to fix this one, though, guys? Yeah, and so we had 11 total letters, and from those 11 total letters, we were only choosing 3. Why don't we just throw that in? Because you guys have an NPR button, true? So why don't we just do our fraction? Why don't we just do our NPR? I mean, we could write out the factorial formula, which is good and all, but you could also just go get your NPR. If any of you guys have a calculator that's a little bit older and you don't have all the cool options under alpha window, it's okay. Just go to math and prob. If you have the old school one also, you might need to type the 11 first and then type the NPR. Some of you might have already figured that out. But type the 11 first, then the NPR, then the 3. Others of you can actually put the 11 in the N spot, put the 3 in the R spot. And then we have 6 and 2 is 12. So, oh, it's another gross 0.5 one. 82.5, right? which we would round. Anybody else need to reach out for help in their calculators really quickly? Well, probability, Joe, it's helpful. It's helpful, but it's not always precise. So how there could be a 0.5 is...
Wait, we're not using all the 11 letters from professor. Because there's letters.
Professions.
Like there's 3 S. You get 3 S, you still get 3 S.
Say it again.
Like there's 3 S in the letter,
Mm-hmm.
the letter professor.
Mm-hmm.
In 1 digit, you get 3 S. They're still S. They didn't change. So
Which is why we're dividing by 3 factorial, right?
no, I mean, isn't it a 3 to 3 letter arrangement? We shouldn't start with 11 because 11 is not the total.
What is the total?
The total is 11 minus 2 minus 1. We should ignore 2S and all that repeated.
What Joe's trying to say is that there might be a better way of analyzing this word, because you could think of all of the S's as just one letter, as one type of letter. Now, the rest of them are only one. Oh, no, there was something else. O was repeated. So we could think of, hey, there are S's, that's one type of letter. There are O's, that's another type of letter. And then we could go to the P's and the R's and the F's and the E's and the I's and the N's, which would mean there are 9 different types of letters, choosing 3.
It's 42.
But the dilemma is, Joe, if we do that, the 9 different types of letters, then we couldn't do this, because that wouldn't be working with our individual letters. This wouldn't apply. And then if we did the 9P3, we'd be ignoring the possibility of getting all the S's or a couple S's with multiple I's or multiple O's. Like, we would ignore some options. Yeah, but we have 3. But we can go ahead and talk about this a little bit longer. The way that you're saying also, in a sense, could somewhat add up, but it's going to be imprecise as well. We need to finish off with combinations really quickly. Even though I haven't spent a lot of time, and I wasn't going to spend a lot of time on it as far as the math, because you guys have already seen this version of combination. You've already seen this version of combination. The n factorial over n minus r factorial, back from the binomial theorem. But what you might not have realized is it's actually also NPR all over r factorial. Well, wait a minute. We've just done a lot of things where dividing is taking away options that don't apply, or that aren't distinguishable, so they can't be counted separately. So what's going on if we're dividing r factorial from NPR? Just real quick off to the side, NPR, oh, my marker's not working. NPR, remember, isn't he n factorial all over n minus r factorial? Why would you divide by another r factorial? Those r things wouldn't necessarily be repeats. They wouldn't be the exact same thing. But r factorial, wouldn't that be the way of arranging r, oh, that does not look, that looks like robots, but not. R objects. That was meant to be a space. Why would you be dividing NPR by the arrangements of just the R objects for a combination? What did I say yesterday about combinations? Order doesn't matter, and my example was a combo pizza, right?
Yeah.
And we went to lockers, but then lockers aren't really combinations. So let's say this poor little pizza place, let's say you're making a pizza at home. There you go. That makes sense why toppings would be limited. What toppings might you have at home to put on a pizza? Let's leave off cheese and sauce. Let's just assume that's there, and if you don't like that, something's wrong with you. So what else? Pepperoni, what else? Pineapple, sounds good. Olives. Salsa. We'll say the sauce is already established. That's it? Just pepperoni, pineapple, olives? You guys are boring. Okay. Sausage. Bacon? Oh man, I just keep going. A lot of bacon. Okay, yeah, we could. Okay, I have 5 fingers. We'll stop there. So we have pepperoni, pineapple, olives, sausage, and bacon. We're a very non-vegetarian class. Anyway, coming back. We could get a cauliflower crust. Go Trader Joe's. Coming back. Shh, we have 5 toppings. Okay. What if you were only allowed to put 2 of those on your pizza? And I asked for how many different pizzas were possible. Would you do 5P2? Would you do 5P2? How many options for your first topping? 5. How many options for your second topping? 4. Would you do 5P2? But here's the problem. If you did 5P2, wouldn't it say that pepperoni sausage and sausage pepperoni are 2 different pizzas?
Oh, you have to ignore it.
You have to ignore permutations saying they're different because they're not. So how do we ignore they're different but they're not? Dividing by r factorial. Because r is what you are choosing. With my 5P2, I'm choosing 2. Okay, take away the 2 times 1. Take away the 2 factorial. Take away those arrangements. Because pepperoni sausage, sausage pepperoni are not different combos. Yeah, I get they're different orders, but they're not different combos. So we're actually, for combinations, using permutations and saying, but you're a little too intense. You know what? As long as I have these objects, the arrangements don't matter and need to be taken away. And this one down below, the forming a committee, you might or might not have remembered yesterday me talking about if you're electing like officials in different offices, that's permutation because the order is important. Who's the president, who's the vice president, who's the secretary. But guys, are they talking about them having to sit in particular chairs or having particular positions or just being on the committee? This is a combination because it's just about the group of people in the room. I don't care what order. Does that make sense? Okay, so let's think about what we have. A local college is forming a 6-member research committee, so 6 total, having 1 admin, 3 faculty, and 2 students. Are there 3 different categories that are being combined to be the 6-member research committee? What have we learned in this section that we should do when we have multiple things being put together? Like a shirt and a sweatshirt and a pair of pants and shoes and socks and what happens when we do and when we're putting multiple things together in one? Multiply, right? So we need 1 admin. Wait a minute, but don't we have lots of options for admin? We have 7 options, right? So out of those 7, how many are we choosing? Order doesn't matter, just 1. Okay, but what's another piece to this committee? 1 admin, check. 3 faculty members, okay? So 3 faculty. Do we have any, or how many do we have to choose from for that? Okay. So out of 12, we're only choosing 3. I don't care the order. I don't care how they're chosen, how they sit in the chairs around the table. I don't care. Just order doesn't matter. 12, choose 3. Then what's the last piece? So then, how many total? Got him, coach. Throw it in. The committees are just groups. Doesn't matter the order. Where's something else that order won't matter? Pizzas, committees, they're just like groups of people in a room. How about maybe like hands? Not hands, sorry. When you're doing cards, right? If you're playing Uno, if you're playing, well, you probably don't know Dutch Blitz. If you are playing poker, you just care about like what's in your hand, right? Does it matter what order you've put them? I mean, for you, yeah, but as far as your cards? No. It just matters the hand in front of you, right? Scrabble tiles, same thing. If you're just picking Scrabble tiles, now, if they're asking about arrangements or the ways of putting them down, yes, order is important. But if it's just like, what do you have? The group, doesn't matter. Ice cream doesn't matter? Toppings? Sure, sounds good to me. Someone's hungry. All right, so, oh, we're done? Really? That's it? Oh. Well, Maybe we'll just stop here then today. Let's summarize everything we've done in section 9.6. Then I'll let you guys write down homework. Hold on, pause, pause, pause. This is important for 9.7. When facing a problem involving counting, you need to be able to figure out what you're supposed to be using. So 3 of the questions that I think are super helpful, and the book agrees, as far as analyzing a problem, a situation that's been given to you where you have to do the counting up of how many different possible ways something can happen. First of all, ask yourself, is the order important or not? Is the order important or not? So am I thinking permutation or combination? And does the problem involve 2 or more separate? Now, they say events, but guys, this is a very particular probability vocab term. Events, it doesn't mean like specifically, I don't know, there's like a concert going on, like that sort of event. It can literally be like, well, you need so many admins, so many 3 events or 3 pieces to the whole. Does that make sense? Choosing a shirt versus pants versus shoes, different events. So if there are 3, well, technically 2 or more separate, then that's when we do our fundamental counting principle. So if there's a permutation, order is important, we're using NPR. If order is not important, NCR. And then the fundamental counting principle, we can always use our idea of multiplying separate events together. Cool? Section 9.6, if you have not gotten the homework written down yet, let me go ahead and put that on the screen. At the same time, I'm going to turn in your book 2 homework to see if anyone has started and has gotten stuck yet. And if not, maybe I'll just give you a couple hints just because. So if you guys want the homework, here it is. Let me freeze the screen for just a second. Meanwhile, I'm pulling up the webcam so we can peek. Excuse me. Thank you. To see if there's anything in particular that we might want to be careful of. Going away in a couple more seconds, so if you guys do need the assignment and haven't written it down yet, why don't you grab out your phone real fast, take a quick pic, because I am going to the book in 5, 4, 3, 2, 1. All right, let's see what's going on in homework. Yeah, there's some vocab up above, but what do you guys notice about the first section of homework? Yeah, it's numbers that we can kind of like think up, count out in our heads. But then what starts in number 15? Yeah. But word problems that you can summarize. Now remember, are you supposed to be writing, well, supposed to. Do you need to be writing paragraphs of information in your homework? But are you supposed to be summarizing problem details? So for instance, if I was to give you number 15, how would you guys summarize this information as far as writing down the problem and the directions? Well, the directions are not that big a deal. Can't you just do like 1 of 3 amps, 1 of 2 CDs, CD players? Oh, that's awkward. That's a while ago. 1 in 5 speakers. Find the number of system configurations, right? Or number 16, jobs, chemist, statistician. 5 for chem, 3 for stats. How many ways can they fill, etc. So guys, feel free, please, 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 to summarize the information, to use numbers in lieu of words when possible, etc. But as you're reading through, you need to be thinking of when is order important and when is order not important. For instance, guys, is the order of how we're putting together the system or the pieces that we're putting together, is the order in which we choose them important? Or is it just important what's in there? Yeah, as far as choosing, as far as buying from the store, it doesn't matter what order you choose them. It matters what you're going home with. So this one would be a combination. How about this one? If you're trying to fill 2 jobs, a chemist and a statistician, does it matter what order they choose them or just who's the chemist, who's the statistician? Once again, combination. Okay, well then hold on. When is order going to be important? In how many ways can the 8 people board the aircraft? Why is order important there? Yeah, the ways of boarding are like the arrangements of the people getting onto the plane. Do you kind of see how, if you can fill in with our notes, if you can fill in the word for permutation, arrange, or order, arrangement is probably one of the most common one. If you can restate the problem using the word arrange, then it's a permutation. If you don't need to, or if you cannot, then it'd probably be a combination. Besides that, in homework, though, we talked about how, lo siento, wrong one. You're going to have the vocab, you're going to have your integers, you're going to have some word problems, and, well, it's not all word problems, is it, guys? No. Yeah, some with repeated letters and some with NCRs and NPRs. So have your calculators with you. Don't be scared of the word problems. Some easier ones are coming, then maybe some more word problems, but break it down. Analyze it. Peace. Bye. Peace. Bye, guys. Not today. Not either. No. You can catch me during lunch for a little bit if you want. Okay.